This video is about solving linear equations. Equations show that two expressions are equal. So for example, the equation x plus 2 equals 10 says that the expression x plus 2 is equal to the expression 10. When you solve an equation, you are finding the value or values of the variable that make the equation true. So in the example that I just put up there, there's only one solution for x, that variable, that would make that equation true. And that solution is x equals positive 8. Because if you take that 8 and replace x with it, 8 plus 2 does equal 10. That gives you a true statement. To solve this linear equation, and all that linear means is that the exponent on our x is a 1, it's invisible 1, we're going to use inverse operations on both sides. The inverse operations are addition's inverse is subtraction, multiplication's inverse is division. And those are the four operations that we'll be dealing with here. Addition, subtraction, multiplication, division. I'm going to write this equation a little bit bigger so I have some room to solve it. What I see happening to the x right now is that it's being multiplied by 3, and then it's having a 7 subtracted from it. So I want to do the inverse of those two operations. I'm going to deal with the minus 7 first by adding a 7 to both sides. A minus 7 and a plus 7 would just come out to 0. So this effectively cancels out. Bring down what you have left. I have a 3x on the left side of the equation. Bring down your equal sign. That's very important. And then do the operation 20 plus 7 to get 27. Now the only operation that I have left is 3 multiplied by x. So I'm going to do the opposite of that, which is divide by 3. To show division on both sides, I'm going to use a fraction bar. Fraction just means divide. And on the left, 3 divided by 3 is just 1. And I don't need to show a 1 in front of an x. So when I bring this down, just bring down an x, bring down your equal sign, and then do the operation 27 divided by 3, which is 9. Before I circle that as my final answer, I want to check it in the original equation. If I take the original equation and replace x with 9, I use parentheses when I substitute, leave the rest of the equation alone. Now we simplify the left and see if it comes out to equal the right. So simplifying the left side of this equation, 3 times 9 is 27. 27 minus 7 is 20. And 20 does equal 20, so it gave us a true statement, and therefore this is the correct solution. What if the coefficient of x is a fraction? We have two options for dealing with this. I'll show both. One option is to do very much the same as what we just did on the previous slide. Inverse operations, starting with that plus 1. I want to get rid of it by subtracting 1 from both sides. Plus 1 minus 1 would just give me 0. I have negative 2/5 x. 5 minus 1 is 4. Don't forget to bring down your equal sign. And now to deal with that fraction, I want to deal with the 2 and the 5 all in the same step. I'm going to do that by multiplying both sides of this equation by the reciprocal, which is the flipped upside down version of that fraction, which would be negative 5 over 2. Do the same thing to this side of the equation. On the left, the negative 5 over 2 and the negative 2 over 5, if you were to multiply those together, would just equal 1, positive 1. So really, we can cancel those out. Just cancel them out in the original red. And then bring down the x that you have left. And how do you perform this operation on the right? We have the whole number 4 being multiplied by the fraction negative 5 over 2. If it's helpful for you to see it, you can put that 4 over 1, because every whole number is just a fraction over 1. And when you multiply fractions, you go straight across the top. 4 times negative 5, which is negative 20, over, go straight across the bottom. 1 times 2 is positive 2. This can be simplified, and it looks like the final answer is going to be negative 10. Another option for solving equations that have fractions is to get rid of the fraction in the first step. And this is an especially good option if there are many fractions in the same equation. To get rid of the fraction from the entire equation, what you should do is take the denominator of that fraction, which is 5, and distribute it through the entire equation. You are allowed to do this as long as you multiply everything in the equation by the same value. The equation still remains true. When you multiply the whole number 5 by the fraction negative 2 over 5, it's like there's a 5 on top and a 5 on bottom, and they would cancel each other out, leaving you with a negative 2x. The rest of the equation is still getting multiplied by 5, so we have 5 times a positive 1, and we have 5 times a positive 5. And now you have an equation with no fractions in it. Get rid of the plus 5 by using a minus 5. Do it to both sides of the equation. Bring down what you have left. I see the operation multiplication here. I see a negative 2 being multiplied by x. So I'm going to get rid of it by division. Inverse of multiplication is division. The negative 2 divided by the negative 2 is positive 1, so we don't need to show it. We bring down the x. And 20 divided by negative 2 is negative 10. So by those two different methods, we ended up with the same answer, negative 10. If there are variables on both sides of the equation, you want to get the variables on the same side. Simplify by combining like terms. That means things that have an x in them can combine with other things that have an x in them. And then you solve the equation using inverse operations. So here I have a 3x minus 7 on the left, a negative 2x plus 13 on the right. I want to start by getting my variables on the same side. So I have 3x on the left, negative 2x on the right. Write this equation a little bigger so I have room to show it. I like to start on the side that has the lowest number of x's. So on the right, we have a negative 2, and that is lower than 3. So I'm going to start by moving the negative 2x by adding 2x to both sides. Now, when I add it to the left side of the equation, I'll be adding it to the 3x because those are the like terms. Do not try to add the 2x to the 7 because the 7 doesn't even have an x next to it. Those would be unlike terms and they wouldn't be able to be combined. But I can combine the 2x with the 3x. So I'm going to line those up. Let's put my big addition bar. 3x plus 2x, combining like terms here, gives me 5x. Bring down the minus 7, which hasn't been touched yet. Bring down the equal sign. The negative 2x and positive 2x is 0, so I can completely cancel those out. Even the x is not there anymore. And then I bring down this positive 13. I don't need to show the plus sign in front of it anymore because it's not being added to anything, right? It's just a positive 13. And now I have a two-step equation. I have a minus 7, which I'm going to get rid of by adding 7 to both sides. Bring down the 5x, bring down the equal sign. 13 plus 7 is 20. And now I have a 5 multiplied by x. Opposite of multiplication is division, so I'm going to divide by 5 on both sides, and x will equal 4. And you can always check your answer by plugging it into the original equation. And this time you'd have to replace x with positive 4, both on the left and on the right. So let's see what that looks like. I'm going to replace the left side with a 4, where I see the x. And on the right, I'm also going to replace that with a 4, where I see the x. And now I have to simplify the left and the right to see if they come out the same. 3 times 4 is 12. 12 minus 7 is 5 on the left. Negative 2 times 4 is negative 8. Plus 13 is positive 5 on the right. So because that came out the same, I do know that x equals 4 is the correct answer. That is all.